All right, so here we are once again for AP Stats. We're gonna now do some examples of how we use z-scores to determine significance of individual values within a given distribution. So let's talk about, I'm going to give a couple of examples here. And typically what we'll see on the exam are two types of questions. Either one that can just get the raw data set and then have to calculate the mean and standard deviation, or I might just be given the mean and standard deviation, just outright without having to do any calculations. Now, if we do get the raw data set, we do know already how to do that, and I showed you in the last video from just putting in our numbers and asking it to give me the one variable statistics. So I'm going to start with my first example here, and if you've taken psych, you might already be familiar with the IQ test. So when we administer an IQ test, typically the average score on an IQ test is supposed to be 100 with a standard deviation of 15 points. So again, as we talked about last time, standard deviation means, okay, on average, how much should my score vary from the middle? So that would mean that an average score, and again, we're going to put this in air quotes, average score should vary anywhere from 100 plus or minus 15. So that can be anywhere from an 85 to a 115. Now, again, if we go beyond that, it starts to become more significant. So now let's say, all right, so a person comes in, they take their exam and they say, all right, well, I got a score of 107. So that's above the mean, they're happy, but is it significantly above the mean? So this is where we want to now calculate a z-score. Okay, so I'm going to formalize, which your book shows you, how do we calculate a z-score? So we typically get our z-score is by taking our given data point, whatever we got, our score, minus the mean, and we're going to divide it by the standard deviation. All right, so we'll do it in our case here. So we have I scored a 107. The average was 100. And the standard deviation for this test was 15. So that's going to give me a 7 out of 15, which, and now we'll pull up our calculator, is approximately 0.467. So 0.467, 0.467. So then what does this mean? This score is 0.467 standard deviations above the mean. So that's what we're doing. We're standardizing that distance. So we're not just saying, hey, I'm 7 units or 7 points above the mean. Okay, well, depending on the standard deviation, that might be significant, it might not be. So if I were to change this and say, hey, the standard deviation is just 1 point, 7 is a huge deviation, but it's 15. So that 7 now becomes less significant. So this is why it's important in a z-score. We always are standardizing it. We're comparing it back to its standard deviation to be able to get this number. So we can see here, okay, yeah, it's above the mean, but it's not significantly above the mean. I didn't even go past a standard deviation. And that's why I had said this earlier of just kind of like ballpark looking at the value. All right, now let's say we got another person. They come and they take their exam and they say, oh, hey, I got a 127. Actually, no, sorry. Let's make it, hey, I got a 135. So is that significant? Okay, that's a pretty big score, but how significant is this? So now, once again, I would calculate a z-score. So I would go, okay, 135 minus 100, and then we'll divide it by 15. Okay, so that's going to give me 35 over 15. And then we'll put that into our calculator again. So 35 divided by 15. And now we got a 2.3 repeating. So I'm going to put 2.333. So that means we are 2.333 standard deviations above the mean. Okay, this is highly significant because we just didn't go above the average once. We went above the average deviational value twice. So that's pretty significant. So this is a very important score. This is not just happening on average. This is something that is, abnormal. Okay. So this is where, and this is why we standardize, because again, looking at it from a bigger picture, when, let's say for, you might remember maybe in your elementary school of like, well, if you tested for students that, and I'll tell you for the state of Florida, it's like when students test, score high on the IQ test, how do they get put into what's known as the gifted program? Well, the gifted program has particular conditions, one of which is, one condition to get into the gifted program is to score this 2 standard deviations above what is considered an average IQ score. So a student that would score a 130 or higher would be allowed to have access to those resources and to those programs that are the gifted program. Now, on the flip side, what if you scored significantly below the average score? Well, that is where we have the exceptional education program. And to get access to those programs and services, you would have to score significantly lower on an IQ test in order to gain access to those scores. Now, that's by no means the only measurement to get access to these programs and to these resources. There's other what they call other plans. So there's plan A and there's a plan B in terms of how you get access to these programs. But these are the things that kind of govern how kids are allowed to get into the program or not. So measurement. So this way of doing this kind of standardization allows for us to not just stare at the raw number, but okay, in comparison to the standard deviation, is it significant? So again, as I had said earlier, if a data set is very widely spread like this versus something that might be a tighter distribution, here the data doesn't vary as much, so you don't have to deviate very far in order to be significant. Versus here, I might have to go further away in order to be deemed significant. So that's what we start to see here. Okay, now I have a way now to look at an individual within a distribution and determine, is this a significant point, or is it something that is more common, which would be considered part of the group, so to speak. All right. Now let's go, and now we'll see another use for standard deviation and z-scores, and that is to compare 2 different types of groups. So as an example, and again, something that might be familiar or relevant to you guys is SAT versus ACT. So those 2 exams we know have completely different ways of scoring. So SAT has a maximum score of 1600. ACT, I believe, has a maximum score of 35. So those are 2 totally different scales. So if somebody comes to you and says, hey, I got a 1200 on my SAT, and then they say, well, on my ACT, I got a 21. Okay, those are 2 totally different numbers. So just because this one's bigger than the other one, does that mean that that's significant? What if I were to divide it by the total score? Does that really, again, belie the significance? Which one is a better performer? No, we need to look at it compared to each exam's average score and how on average it deviates. So for our SAT and ACT example, I'm going to go ahead and put some information. So for SAT, I'm going to put here that the average score on SAT was 1100. Standard deviation was 200 points. Now the ACT, I'm going to say the average score there was 20 with a standard deviation of 1 point. Okay, so actually, no, sorry, not 1 point. Let's say 3 points. Okay, so now let's talk about it. So a student scores, they go and they take ACT, and they take SAT as well. So on their SAT they scored was a 1200, but on their ACT they scored was a 21. So which one's the better score? So let's say, okay, now I got to report this to my college. Which one do I want to put on the paper? Because one's going to be better than the other. So this is where we want to standardize the scores. So that's where our Z-score is going to come in. So by converting both of these raw scores into Z-scores, it allows me to now compare them. Because right now they're on two totally different scales. I can't just grab the bigger of the two and say, well, that obviously is better than the other one. I don't know. So we're going to start with our SAT Z-score. So I'm going to take our score, 1200, subtract it from the mean, and divide it by the standard deviation. So 1200 minus 1100, so that's going to be 100 over 200, which gives me a 0.5. So that means while my score was higher than the average, it was only 0.5 standard deviations above the mean. Okay, so I'm still roughly around the average mark. It's not, I didn't even deviate, at the average amount that you would have normally seen. Okay, now what about my ACT Z-score? All right, well, let's go there. So now I got 21 minus 20 over 3. So now this is going to be 1/3, which we know is a 0.333, and it repeats. So again, I see here, all right, yeah, I scored above the average. Average was 20, I got a 21. But again, I see, well, I really didn't score that much higher than the average deviation. I maybe take it tomorrow and I would score a little bit below, but it is not something that is abnormal. Okay, it's just these two. So now if I needed to report one, which is the one that I would want to report? So that would mean I would want to report is this one. It has the higher Z-score. I deviated further from the average here than in the other exam. So this is the one I would rather report to my colleges in my college application if I had to choose between the two scores. So this is where we get like those commensurative scores. So when you've gone to college counseling or you've looked at the score reports you get, they'll tell you like, oh, okay, I got when you score this on the SAT, you should be around this kind of score on the ACT. How do they know that? They're two totally different companies. Are they talking to each other? No, they just collect this information and they know what their means and standard deviations are. They know what the other company's mean and standard deviations are. So then it commensuratively kind of lines up. So yeah, this is a typical kind of performance. Okay, you go to take one test. You really shouldn't be any like better or worse on the other test if all it's measuring is truly your abilities. It's when the scores are radically off that then, hey, something weird happened. Like, maybe you took the one exam in like 10th grade for some reason, and then you never tested again until 12th grade. That could be an explanation for why you have such a significant difference in your score from one, exam to the other. But otherwise, it kind of should float around the same amount. This is also how they can kind of check to see, like, did something significant happen here, because these scores are different. All right, so this is how, again, using Z-score helps us to compare two different groups. All right, so again, just a couple light examples here on using Z-score, calculating Z-score for comparisons of two different distributions. So again, if you found this video to be helpful, please make sure to hit a like and subscribe to the channel, and I will see you guys on the next video.